Okay, so here we are, section 2.4, another one of these sections where we're doing math, but really it feels like we're not doing any math 'cause we're not doing traditional problems. But deductive reasoning. So we've talked about inductive reasoning. That uses patterns. Deductive reasoning uses logic, and it is kind of pattern based, but not in the same way. There'll be specific laws and rules we'll follow. And again, this will probably make more sense in class. I'm just kind of getting the basic ideas out of the way to start off with. Number one, though, law of detachment. Um, the process that detectives use, okay, I'll just read this thing here, to identify who is most likely responsible for a crime is called deductive reasoning. So unlike inductive reasoning, which uses patterns, examples, and observations to make a conjecture, deductive reasoning uses facts, rules, definitions, properties to reach logical conclusions from given statements. So, if you've watched Sherlock, or I think what's the one that's on CBS or whatever it is, the Sherlock Holmes TV shows or movies, a lot of times Sherlock Holmes is considered a deductive detective in the sense that he uses these, oh, this is a fact here and this is a fact here. Now he uses, maybe those facts are based on patterns, but they're still considered facts. So it's basically using facts and statements and arguments to get there. So the first one is the law of first thing is if it's inductive or deductive reasoning. So A from the book says every time Katie has worn her favorite socks to a softball game, she has gotten at least one hit. Katie is wearing her favorite socks to a game tonight, so she concludes she'll get a hit. This is clearly not a fact. It's just luck that when she wears her favorite socks, she gets a hit. So that's a pattern. So she's assuming that using inductive reasoning. But here we go. B, if John is late making his car insurance payment, he will be assessed a late fee of $50. John's payment is late this month, so he concludes he'll be assessed a late fee of $50. That's a fact. If you're late, they make you pay more. He was late, he's paying more. So sometimes it feels subtle, the difference, but a lot of times it's kind of obvious which one's deductive versus inductive. So here we go, 1A and 1B. Um, all of the signature items on the restaurant's menu shown are noted with a special symbol. Kevin orders a menu item that has a special symbol next to it, so he concludes that the item that he has ordered is a signature item. And then B, every time Raul goes to a restaurant on Thursday, Cheese Supreme is the special. Raul goes to the restaurant on Thursday, so he concludes that the Cheese Supreme will be the special. Now, hopefully, you're able to figure out that 1A is the deductive reasoning. And the reason is, the fact they're using is the symbol indicates the special. And he got the special because he has the one with the symbol on it. So that's a fact. 1B is a pattern, so it's inductive, and that pattern is that Thursday special. Restaurants change their specials all the time. Sometimes they keep it consistent for a while, but they can always change their menu. So because he's expecting, well, Thursday always says Cheese Supreme, whatever the heck that is, maybe pizza, I guess, as the special. That must always be the special. Well, not always. Maybe the next Thursday decide to use something different. Okay. Now, law of detachment. Okay. This one is confusing for some people. Hopefully, again, kind of give you the background here, and then in class we can kind of clean this up. So the law of detachment states if you have a conditional statement, so if a P then Q statement is true, and P is also true, or more likely, the way to think of this is P occurs. Instead of thinking true, think if P occurs. If it happens, okay, then Q will happen to be true. So for instance, looking at this, if a car is out of gas, then it will not start. That's our if and our then. And that's true. If a car doesn't have gas, it won't start. Can't start without gas, unless it's an electric car, I guess. We know Sarah's car is out of gas. So what's our conclusion? Her car won't start. So it's, again, they say if it's true and then the Q is true. It's more so thinking if this is a true conditional, if P happens, then Q will happen. Okay, so here's an example to look at. So if two angles form a linear pair, then their non-common sides are opposite rays. So BE or EB and ED are opposite rays. So the conclusion here is they're opposite rays. Well, is this true? Yes, that's by definition of what a linear pair is. If they form a linear pair, non-common sides are opposite rays. That's the more technical definition. We use the definition of the adjacent pair of angles that form a line. So here we go. Now we're going to make the conclusion. Well, EB and ED are opposite rays. That has to follow it is true. Now here's an invalid one. This is kind of tricky. If Mika goes to the beach, she will wear sunscreen. The next statement is Mika's wearing sunscreen. Now this isn't true because the way this works is this is the P. Here is the Q. Okay, if Mika goes to the beach, then she'll wear sunscreen. If P, then Q. Look at what they gave us. They gave us the Q statement this time. Mika's wearing sunscreen. Now, and you know, there's a chance she could be at the beach, but that doesn't mean she's necessarily at the beach. What it might mean is maybe she's outside in her backyard doing, you know, yard work, or in this case, the book says she's at the pool. We just know that she's wearing sunscreen, which she could be at a multitude of places that wear sunscreen. So it's a little tricky. So that's why I like to say, think of it as not if P then Q, and if P is true, Q is true. Think of it as if P then Q is true. If P happens, Q has to happen. But it doesn't work the other way around. Okay. So on this one here, okay, if 3 points are non-collinear, they determine a plane. Okay, so here's our P. If 3 points are non-collinear. Okay, our Q is, whoops, grab that guy. They determine a plane. Okay, now let's see here. Did we get, okay, on our next statement, the P statement to begin with? Okay, what we're told is A, B, and C lie in a plane. Does it say anything about them being collinear? No, this is a completely different statement. We just know they lie in a plane. What could be happening is, let's see if I can draw this. Let's say this is our plane here. Okay, those 3 points could just be anywhere on there. They're not points, they're little segments, but I'm too lazy to do the points. But those guys there are not collinear. They're just on there, A, B, and C are. So this is not valid. Hypothesis did not occur. Okay. All right. 2B. If a student turns in the permission slip, okay, there's our P. Then the student can go on the field trip. There's our Q. Okay. Felipe turned in, or Philippe turned, whatever which pronunciation is, I guess I've heard Philippe and Felipe, turned his permission slip. Hey, that's P. P occurred. So now we're going to say Q occurred. Yep, that's valid. So yeah, valid. It's valid by the law of detachment. Okay, last law, last part here, and then we'll get out of here. Law of syllogism. Okay, now here's, this is really what we're going to do for our proofs, and we'll talk about this in class the next few days. We're going to tie a bunch of if-then statements together. So for example, if P implies Q, and Q implies R are true statements, then we can just basically skip to saying P implies R because we're going to go through right here, Q, and just tie those together. So and this makes sense when you look at an example. So for example, if you get a job, then you'll earn money. Well, this is your P, this is your Q. If you earn money, then you'll buy a car. This is your Q, this is your R. Okay, so I'll do this with color so they kind of stand out. Let's put the P will be in green and the R, which this is P. Okay, wait a second. What am I doing here? I already have green. Mr. Moyer, let's do R's green since that's already green there. Okay. You're better than this. So there's green. And we'll do, I don't know, red or whatever I can get closest to a red. This color here. This will be our P. So if you get a job, oh, that kind of covers it up there. If you get a job, you will buy a car. And then again, this guy here, this overlaps. So basically what we're just going to kind of do is just take out that part there and make these two statements that are long into one shorter statement. So if you get a job, then you'll earn money to buy a car. If you earn money, then you'll buy, if you get a job, then you'll earn money. If you earn money, then you'll buy a car. We'll just say, hey, guess what? If you get a job, you'll get a car. But that only works if all of these two statements are true and make sense. So For another example real quick, determine which of the statement follows logically from the given statements. If you like musicals, then you will enjoy theater productions. If you are an actor, then you will enjoy theater productions. Okay. So if we go here, if we look at this, here's our P. Here's our Q. I know it doesn't jump out there. Okay. Here's the tricky part though. This is a new statement. So this would be our R. This would be our Q. So if we look at our statements, it isn't P implies Q, and then Q implies R. This is P implies Q, R implies Q. So these first three don't follow. It actually doesn't follow any of them. It's not a valid conclusion. Okay. All right, now that was an example that didn't work. For homework for you then, okay, you have number 4. Okay, so your job is to figure out of these two statements here, if you do not get enough sleep, then you'll be tired. If you are tired, then you will not do well on the test. Which one of these 4 statements is valid? Okay, or if 3 statements, which of the 3 is valid? If not, then there's no valid conclusion. Okay, so this is one of the tougher sections. If you've got questions and you're everywhere, come on in. Come in the morning. I will be more than glad to kind of help you walk through it. It is a little better one-on-one. Okay, so see you tomorrow.